We'll see the range of a function, range of any function. So if we have any function, let's say y is equals to fx, this x is basically called the independent variable, and this y is basically the dependent variable. So the acceptable values of x, they are called the acceptable values of x. They are basically called the domain, and the values of y obtained by acceptable values. So we have acceptable values of x. They are the if you want to find the range of function, we have to substitute the acceptable values of x in the function and we get the y. So the value of y obtained, they are the range of function. So that's why we say that the range is normal. We say that set of all, so set of all output of a function, is called the range of a function, okay. Now we'll see how to find the range of function. This is little bit difficult than finding the domain is a pretty easy, but finding range is little bit difficult. So we will see how to find the range of function. So we'll see how to find the range of function. Okay, so there are few methods. Broadly I decline the range of functions. So there are some very basic functions. So if we have a basic function, we should know the graph. So using graph we can find the domain as well as the range of functions. So if you have basic functions are there, we should know the graph of that basic function, and hence we can easily know the what is the range of that basic function. Second is the transformation of a simple transformation of a basic function. We will do some kind of transformation. Transformation means some addition, division, or some kind of composition. So simple transformation of a basic function. Then third, if the composite function, sometimes we deal with a composite function. Then third method is using the concept of composition. The next is this also useful. This is something the extension of composite function. This is something extension of composite function. So basically the method is basically I call it the substitution method. Substitution method. Then next is the using the concept of monotonicity. Using monotonicity. Okay, that means we should know the increasing or decreasing concept. We should know the increasing decreasing concept, and then using the increasing decreasing concept we can find the range of function. The sixth method is, it's a very algorithm based method. So suppose the function is of form L by Q, or the linear upon quadratic, or quadratic upon quadratic, or quadratic upon linear. Okay, so if the function is of this form, then there is a set algorithm. So we'll follow this algorithm to find the range of a function. The second method is arithmetic mean greater than geometric mean inequality. So using the inequality of arithmetic and geometric, we can find the range of a function. The eighth method of finding the range is for trigonometric function. So the trigonometric, because trigonometric something a broad topic, broad chapter. So we'll see the trigonometric function has a specific way of finding the range, some easier way. Obviously, you can application of derivative concept, but there is a some set method for trigonometric function so that we can easily find the range of a function. And obviously next method, some specific method. Okay, I say there are some function which do not fall under this category, so we'll use specific method. And 10, this is not in the part, this is something using application. This is very lengthy method using application of derivative, method. So this we normally avoid this method. Okay, we will avoid. Obviously this is the general method for any function. If we want to find the range of any function, this is the very general method, but this is quite lengthy, so we will avoid using application of derivative method. So we'll go by the first method, that is a basic function. So basic function, that means we should know the graph of function. We should know the graph of function. Okay. So in graph, basically you know what is graph. So if you have any graph, let's say this is the graph of a function. So range, what is the range in case of graph? Range is the values of y where the graph exists. In layman, so just like here, let's say this value is -3 and this value is, let's say, 6. So basically the values of y the graph exists is the -3 to 7. So in this case the range of function, this particular function, is basically -3 to 6. Okay, so if we know the graph, we can easily see the values of y where the graph exists. That is basically the range of function. So let's see one by one, we'll see all the function. First let's say talk about the algebraic function. So in algebraic function, let's say constant function. So constant function means something y is equals to 2, okay, or in also fx is equals to 2. So this is any function fx is equal to some k where k is the constant. So in this case you observe that, let's say this is x, this is y, and the function is, let's say, 2. So the values of y where graph exists is just a 2. So in this case the range of a function is just a 1 value 2, or in general any constant function fx is equal to k, the range of a function is just a 1 value k. Okay, so range is just a 1 value k. So this is the constant function. Next let's say talk about the linear function. Linear function is obviously fx is equal to, let's say, ax plus b, any linear function. So obviously this represents a straight line. This is just a straight line. So this is y is equal, let's say, axb. So normally if the b is not 0, I prefer, if b is not 0, try to convert x upon p plus y upon q is equal to 1. So here this is called the intercept form of a line. Okay, so obviously in this case the x intercept is, we know that is p comma 0, and y intercept is q, so 0 comma q. So we know these 2 points through which the line passes, so we can easily now draw the line. So this is how we can draw the equation of a straight line. And obviously if we can talk about the any line y is equal to ax plus b, so the range is will be all real values, -infinity to infinity. Okay, or sometimes restrict also. So let's say if I say that find the range of function fx or y, fx is equal to 3x plus 4, where x, let's say x is restricted from -2 to 6. Suppose find the range of function fx equal 3x plus 4 where x is -2 to 6. Find the range. What is the range of function? So this step is first draw the straight line. So 3x plus 4 or y is equals to 3x plus 4. So first draw the straight line. Obviously we'll convert into intercept form. That means 3x minus y, or let's say I'll do like this, minus 3x plus y is equals to 4, and we divide. So basically x upon p plus y upon q is equal to 1. So what is intercept form? The right hand side is 1. Right hand side value is 1, and the coefficient of x in numerator. In numerator, the coefficient of x is 1 and the coefficient of y is 1. Okay, and obviously we'll have this is plus sign. So whatever minus that or any coefficient of x in numerator, that all goes to the denominator. So we should only have a denominator values and all other values is 1. So we'll try to convert like this. So obviously this is we'll make x upon 4 minus 3 plus y upon 4 is equals to 1. So we'll have able to convert the right hand side as 1, but still the coefficient of y is 1 here, but coefficient of x is minus 3 here. So what we'll do like this: x is equals to minus 4 upon 3 plus y upon 4 is equal to 1. This is how we can draw a straight line. Now see, it satisfies the criteria of an intercept form, that is right hand side is 1. The coefficient of y in numerator is 1. The coefficient of x in numerator is 1 and plus. So all the terms which is values or any coefficient, they all goes to denominator. Now we know that the x-intercept is minus 4 upon 3 comma 0, and the y-intercept is 0 comma 4. So we can easily draw the straight line. Minus 4, let's say this is 1 2, so this is around here minus 4. So this is minus 4 upon 3 and this is 0, let's say this is 4. Now joining these 2 points we can get a straight line. So this is a straight line, but they have asked to find the range when the values of x is restricted. This is from minus 2 to minus 6. Minus 2 minus. So this value minus 2 and somewhere is the 6. Okay, that means from this to, let's say, this value. So we have to only consider the values of x is minus 2 to 6, that is the graph from minus 2 to 6 is the yellow one. This is the graph we need to consider for finding the range. So it's a constraint. Okay, so this x is constraint here, minus 2 to 6. So minus 2, the value of y will be, so at x is equals to minus 2, y is equals to 3x. Minus 6 plus 4, that is minus 2. So the value is minus 2, and x is equals to 6. The value of x is, so 6 3 18. 18 plus 4 is equal to 22. So that means 22. So the values of y where the graph exists is from minus 2 to 22. So therefore the range of function is minus 2 to 22. So this is how we find the range of function. Okay. So this is the case for a linear. Now let's third talk about the quadratic function. Quadratic function. Okay. So in case of quadratic function, let's say fx is equals to ax square plus bx plus c. This is quadratic function. Obviously a should not be 0, otherwise this function is turned out to be a linear. So we are talking about the quadratic function. So for quadratic function, the graph, how the graph will look like. So if a is positive, so basically in case of quadratic function you should note down that the quadratic function is a parabola, a specific type of parabola. Specific type of parabola with axis of symmetry. is parallel to y-axis. Okay, so the parabola can be this can be parabola, this can be parabola, this can be parabola. There are many ways to find a parabola. So it's that type of parabola whose axis of symmetry. So you understand, in case of any parabola, you should know some terminology. It will be useful. So in case of any parabola, this line which divide the this is the line which divide the parabola into two halves. This is basically called the axis of symmetry. Why I am saying axis of symmetry? Because this part is symmetric of this part about this line, and this particular point where this turning is happening, this is called the vertex of parabola. Vertex of parabola. This is a very general parabola, but if we talk about the quadratic equation, in that case the axis of symmetry will be parallel to the y-axis. So in case of quadratic equation, someone said, okay, plot the graph of ax square plus bx plus c. This is a specific type of parabola, in which case the parabola will look like something like this. So we observe that here the axis of symmetry is, this is axis of symmetry which is parallel to y-axis. It can be anything. It may be like this or like this, anything. But the condition is that the axis of symmetry will be the parallel to the y-axis. So this is the axis of symmetry is parallel to the y-axis. So this axis of symmetry is basically a line which divides the parabola into equal halves, and it passes through the vertex of a parabola. So two things are there. So in case of parabola, either it is opening upward or opening downward. So you should know that while plotting, if A is positive, then parabola will be opening upward. Opening upward means like this. If A is negative, then the parabola is opening downward. That means it is like this. So we should know, whenever we want to plot, two things are required. One is the either it's opening upward, opening downward, and few more things are required, that is the vertex. We should know the vertex of parabola. So first, if you want to draw the parabola ax square plus bx plus c, we should know whether parabola is opening upward or opening downward. And second thing in parabola is the vertex. So vertex of parabola. So there are two ways of finding the vertex of parabola. First way is just using this particular coordinate. So x coordinate of vertex is given by minus b upon 2a, and the y coordinate of a parabola is minus d upon 4a, where d is the discriminant, is given by b square minus 4ac. So the vertex is given by like this, minus b upon 2a minus d upon 4a. This is the one way method of finding the vertex. And the second method of finding the differentiate. So the y is given to be ax square plus bx plus c. If we differentiate dy by dx is equal to 0, that will give the x coordinate will be nothing but the vertex of parabola. So we will differentiate here. So 2ax plus b is equal to 0. That simply means x is equal to minus b upon 2a. So the x coordinate of parabola is minus b. So x vertex is minus b upon 2a. And for y coordinate, obviously you have to substitute the value here. So a xv square plus b xv value plus c. So we'll substitute the value of xv, then we'll get the y coordinate of a parabola. So there are two methods of finding the vertex of parabola. Either you can have minus b by 2a x coordinate and y coordinate is minus d by 4a, or we have a differentiated, we'll get the value of x coordinate of vertex, and substituting the x coordinate in the function we will get the y coordinate. So there are two methods, and 1 2 3. Okay, so there are, if you want more, I think for finding range this much is sufficient, but if you want, you can, while drawing or while plotting the parabola graph, we should know the y-intercept. What is y-intercept? Where y-intercept where x is 0. That means y is equals to ax square plus bx plus c. So obviously we'll substitute x is equals to 0. So y is equal to c. So in case of the parabola, the y-intercept is 0 comma c. Okay. So these three things are some, but finding range this much is sufficient. In fact, vertex and the point 1 that is opening upward or downward, and the vertex, that is sufficient. Okay, let's plot a simple graph. Let's say I am plotting the graph. Y is equals to x square minus, let's say 4x plus 3. So I have to find, obviously a is 1 here, that means it will be opening upward, first point, and second point is vertex. What is the vertex of a this parabola? So you can either use first method. So let's say I am using the second method for your understanding. So if I differentiate dy by dx is equal to 0, I get 2x minus 4 is equal to 0, or x is equals to 2. So the x vertex is 2. Now for y vertex we will substitute the value of 2 here. So 2 square minus 4 into 2 plus 3, that is 4 minus 8 plus 3, that is minus 1. So the y coordinate of a vertex is minus 1. So the coordinate of vertex is 2 comma minus 1. And if we talk about the first method, let's talk about the first method also. So x coordinate is minus b upon 2a. So minus b is minus 4 and a is 1, so 2. So that becomes 4 upon 2, that is 2. And the y coordinate is given by minus d upon 4a, where d value is b square minus 4ac. So b value has a 4, so minus 4 square minus 4a value is 1 and c is 3. So 16 minus 12, that is minus plus 4. So the y coordinate will be minus 4 upon 4, a is 1, so that is minus 1. So the vertex has a coordinate 2 and minus 1. So either you can use the differentiation method or you can use the formula method to find the vertex. Now these two things are known, so we have to plot it. And obviously the third step is, so the first step was find whether opening upward downward, second step is the vertex, and third is the y-intercept. So y-intercept obviously 3. So the y-intercept will be on, y-intercept means the intersection point on the y-axis, so 0 comma 3. Okay, let's plot it. Vertex is 2 1, so let's say 1 2 and this is minus 1. So here is the vertex, this is the vertex, and it's opening upward, and on x coordinate it is cutting on 3. So let's say this is 0.3, so 0 comma 3. So while plotting, so this is something like this. Okay, I have drawn just a rough graph, not exact graph, because we need to just find the range. For range, this much is sufficient, this information is sufficient. So this vertex is 2 comma minus 1. Okay, now by looking at this one, so ax square plus bx plus c, obviously what is the range? The minimum value of a function is y value is minus 1, and obviously it goes to what this particular arrow means, it extend up to infinity, so the minimum value is minus 1, the maximum is infinity, so this is infinity. Okay, so now you understand that any function y is equal to ax square plus bx plus c, where if a is positive, the range of function will be minus d upon 4a to infinity. Okay, minus d upon 4a to infinity. And same way, see, if I drew a graph like this, obviously this is a positive. In this case, the vertex value is, y vertex value is minus, or this vertex is minus b upon 2a minus d upon 4a. So the minimum value is of y is minus d by 4 and maximum is infinity. And same way, let's say this graph has a opening downward, let's say a is negative, the vertex is still minus b upon 2a minus d upon 4a. That values will automatically take care based on a negative value. So the vertex is minus b by 2a and minus d by 4a, but since a is negative, the minimum value goes to infinity and the maximum value goes to minus d by 4a. So in this case, if a is negative, the range of function minimum value is minus infinity and maximum value is minus d upon 4a. So this is the how we find the range of a function. Okay, and let's say if I ask you a question that find range of function x square minus, same question, let's say 4x plus 3, if x is, let's say I take the values from minus let's say minus 1 to 10. Okay, so if x is restricted from minus 1 to 10, so again we have to draw the graph. So we already drew the graph. So it was 2 and minus 1 and 3. So the graph was something like this. The vertex was here, this. It will goes up to infinity, and here it also goes to infinity. So the we are given to find from minus 1 to 10. So minus 1 will be somewhere here, and 10, let's say somewhere here. Okay, somewhere here. So minus 1, okay, minus 1, we need just for finding range, we don't want a accurate graph, we need some approximate graph. Okay, so minus, so that's why I am not bothered about this 2 and 10. I only know that okay, 2 is the vertex one. It does not matter that this is 2 distance, this is 10. So distance, you automatically know that what this graph means. So minus 1 to 10. So minus 1, the value will be somewhere here, minus 1, and it goes to somewhere 10 here. So the function from minus 1 to 10 will look like this. Okay, only this much portion of the graph should be considered, because x we have to consider from minus 1 to 10. So minus 1 to 10, that means we need to consider only this much portion of the graph. So obviously if I talk what is the minimum value, so minimum value is, before that, let's, what is the value here? Minus 1. So x is equal to minus 1, the value is, so x is equals to minus 1, the value of y is 1 minus plus 4 plus 3, 4, 5, 8. So this is the 8 value. And if I say x is equals to 10, the value of 10 is 100 minus 40 plus 3, that is 63. So this value is something 63. Okay, so you know that the values of y, the graph axis, the minimum value is this. So this is the minimum value of graph. Okay, this is the y minimum value, and this is the maximum value of graph, y maximum. Okay, the minimum value is this and maximum is this. So the range of function will be minus 1 to 63. Okay, got it. So don't think that range is, sometimes people think okay, it is from minus 1 to 10, so range will be, the minimum value of range will be minus 1 and maximum value of range will be at x equal to 10. No, you have to draw the graph and see what is happening. So this is this one. Next is let's say cubic function. Cubic function. So cubic function, I am just talking about a simple cubic function, y is equals to ax cube plus b, because other cubic function will be difficult. So if a is positive, so it will be something like, so let's say b is, if b is 0 case, so y is equal to ax cube, the graph is something like this. So this point where they sudden turn, so it seems to be something downside, and this is upside. Down means it's like this side, and upside means like this. So here there is the intersection of opening downward and opening upward. There is something called concavity. This is concave downside and this is concave upside. So the intersection of the point where the concave up and concave down intersect, that point is called the point of inflection. This is called the point of inflection. So if b is 0, the point of inflection is this, and obviously we know that it goes to minus infinity, it goes to plus infinity. So the range of the function ax cube is obviously minus the range of the function will be minus infinity to infinity. Okay, and if you want to draw the graph of, let's say, x cube plus b, so obviously you have to shift by distance. So it's not necessary, but if you draw the graph, so let's say this is shifted at b, so concave down and concave up. So this is the graph of ax cube plus b. This is the point shifted 0 comma b. So obviously this is also both the graph, either ax cube plus b, or this is the way we draw it. So the range is minus in plus infinity, and in general I can't, it's very difficult to draw the graph of any general cubic function, but any of the cubic function ax cube bx square plus cx plus d, okay, range of function will be minus infinity to infinity. Okay, or in general any cubic, you should know any cubic or any odd degree polynomial, odd degree polynomial fix has a range minus infinity to plus infinity. Any odd degree polynomial has a range minus infinity to plus infinity if no restriction on x. I think you agree why I am saying. See, just like this is, it goes to minus infinity plus infinity. But if someone asks you that, okay, find the range when x is from, let's say, minus 1 to 5, so then we should know the graph, exact graph. Okay, so if a cubic function, we don't know graph, it may be sometime like this, it may look like this also. Okay, graph, we don't know the exact graph, so it's very difficult to draw the exact, not difficult, you have to use the application of derivative, so it's little bit more steps are there, so I'm avoiding that part. So in case of any cubic or any odd degree polynomial, the graph will be something like this only. Okay, so we don't know where up and down, but at least we know that the minimum it goes to minus infinity and maximum it goes to plus infinity, and since it is the continuous, it will contain all the values of y. So that's why any odd degree polynomial has a range minus infinity to plus infinity if there's no restriction on x. Obviously if you restrict, we don't know what is the how the graph look like, because based on restriction we should know the exact graph, and then only we can find the range. But if there's no restriction, we can directly say that any odd degree polynomial has a range minus infinity to plus infinity. For example, if I say that find 3x to the power 7 plus 2x square plus x. Okay, so there's no restriction on x in this particular function, so we directly say that the range of a function will be minus infinity to plus infinity. Why? Because this is odd degree polynomial. Okay, Acha, by the way, you should know that it should be polynomial. If I ask you find the range of let's say x cube plus 5x square plus 7 by x, so here this is not a odd, first of all this is not a polynomial. So in this case we can't say that the range is minus infinity to plus infinity. Okay, this is not a polynomial. Forget about odd, this is not a polynomial. Since this is not a polynomial, we can't have such kind of general argument. Okay, we can't say that okay it's odd degree polynomial. No, it's not odd degree polynomial. In fact, it is not a polynomial. Since it is not polynomial, so we'll not able to say what is the range. Then we need to have further analysis, but we can't say that the range is minus infinity to plus infinity. And you should also know that any even degree polynomial can never have range minus infinity plus infinity. That is important thing. Any even degree polynomial can never have range minus infinity to plus. Why I am saying so? Because the thing is, any odd degree polynomial can have like this, something like this, something like this. So it always x, if x is infinity, y value goes to infinity, and if x is minus infinity, y goes to minus infinity. So it covered from minus infinity to plus infinity in case of odd degree polynomial. But if you talk about the even degree polynomial, they will something like this. Okay, that means if x is infinity, then y is infinity, and if x is minus infinity, then also y is infinity. So x infinity, y goes to infinity, x is minus infinity, still y goes to plus infinity. So we don't know the minimum value in this case. So minimum value is obviously not minus infinity, some fixed value is there. So that's why in the case of even degree polynomial, we can never have a range minus infinity to plus infinity, because if x is infinity, y is infinity, x is minus infinity, then also y is infinity. Okay, so this is the polynomial. I have talked about the polycubic function and extended for a odd degree and even degree polynomial. Okay, so let's extend this part. I think y is equals to x to the power n. N is any even natural number. Okay, y, let's say x square, or y is x power 4, or y is equal to x power 6. All this graph will look like something, nature is same, something like this only. Okay, some difference is there. So this is, let's say, x square, no, this is x, yeah, this will be x to the power 4, this is x to the power 6 graph. Some difference is there, but we know that y is equal to x to the power n when n is any even natural number. The range of functions is always from 0 to infinity. The minimum value is always 0 and maximum value is infinity. In case of x square, x to the power 4, or x power 6, they look exactly, the nature is same. Similarly, if I talk about y is equal to x to the power odd natural number, okay, that means y is equal to x cube, or y is equal to x power 5, or x power 7, something like this. In this case, the graph will have this nature. Like this. So in case of cubic or 5 or 7, the graph is something like this only. Okay, so in this case the range will be minus infinity to infinity, and let's say this is x square graph, and let's say x to the power 4 graph, let's say x to the power 6 graph, and so on. So you observe here, all the graph has the same nature. The red one is the x square, and the blue one is the x to power 4, and the green one x to power 6. So all have a same nature. Okay, only thing is that this value. So this is at x equal to 1, all value is 1. So x equal to minus 1, all x square, x power 4, x power 6 is 1. So between 0 to 1, the red one, that is x square, is the higher value than other two, and beyond x is equal to 1, the red one, that is x square, has a lower value than other two. Similarly, from 0 to 1, the x to the power 6 is the lowest one, and from beyond 1, the green one graph, that is x power 6, has a higher values, and the symmetry is in the negative side. So that means they have a same nature, graph of nature is same. Okay, similarly, if you have a, let's say, cubic 5 7, okay, so you observe this, they have also the same, cubic and have the same nature. So if I ask you, find range of y is equals to x to the power 21, where x value is from, let's say, minus 2 to 3. Okay, so you know that it's a cubic. So cubic means the graph will always be like the same nature. So we have to consider somewhere the minus 2 and somewhere the 3. So that we have to consider only this much portion of the graph. Okay, let's make it little bit. Let's say minus 2 open and 3 close. Okay, minus 2 open, 3 close. So at minus 2, the value will be minus 2 to the power 21, that is minus 2 to the power 21, and at the value of 3 is 3 to the power 21. So the, and since minus 2, x equal to minus 2 open bracket. So that means this will be whole. Okay, let's make like this whole, this, and it goes like this, and there is a close bracket. Whole means at x equal to minus 2 will not get the value. So the range of this function will be open bracket minus 2 to the power 21 to 3 to the power 21 close bracket. So this is how we find the range of function. Now let's talk about the square root function. Square root function, or extend it to, so square root function is something x root. So in this case the graph is something like this. So we know that this is square root, so x will be positive, x can't be negative because it's a square root, and this is absolute value, so always positive. So this is the value. So in this case the range of function will be 0 to infinity. This goes up to infinity, this goes up to infinity, and this is the 0 value. So the square root function has this nature, 0 to infinity. And in fact if I say any natural number, they have a same nature, like this only. So they have the same nature of graph is same. Obviously some difference, 0 to 1 the value will be lower or above, but the nature of the graph will be same for any event root. This is something event root. Okay, n is any natural number. Okay, just if I ask you find the range of x to the power 6, where x, let's say, goes to 2 to 3. So we'll draw the graph of, make it like this, 6 root of x, y is equal to 6th root of x, where x is from 2 to 3. So the graph will be same, just like a square root function, and we have to look at from, let's say, 2 to 3. So the 2 value is 6th root, and 3 value is the 6th root. So obviously the graph is this only. So the minimum value of y is 6th root of 2, and maximum value is 6th root of 3. So range of this function will be 6th root of 2, and maximum value is 6th root of 3. So this is the range of this function. Similarly, let's talk about the 6th point, cubic root function. Cubic root function will look like this. Like this. So it goes to plus infinity, it goes to minus infinity. So in this case the range of function will be minus infinity to plus infinity, and I can extend it. So if I say y is equal to 2n plus 1th cubic root x, they have the same nature of graph. Nature of graph is same nature of graph as cubic root. Okay, so same nature of graph. So in this case also the range of function will be minus infinity to plus infinity. Any function, let's say cubic root or 7th root or 9th root or 2020 3rd root, the range of function will be minus infinity to plus infinity. Okay, so let's talk about it. I want to finish the algebraic portion. Let's say 7th one is the reciprocal function. Reciprocal function. Reciprocal function means y is equal to 1 by x. So y is equal to 1 by x. The graph will be something like this. It's a hyperbolic function like this. And then now again I am extending in y is equals to 1 upon x to the power any odd natural number. They have the same, the nature of graph is same. Graph is same as y is equal to 1 by x. That means if I ask you find range of y is equal to 1 x to the power 21, where x is, let's say, minus 1 to 6 open bracket. I have to find this range. Achha, by the way, the range of this function, observe that the minimum value is minus infinity and maximum value is infinity, but x is equal to 0 is not there. So in this case, we say range of function will be minus infinity to infinity except 0, or we can write other form, range of function is minus infinity to 0, 0 has open bracket, then union 0 to infinity. Either we can write all values except 0, or we go up to minus infinity to 0 and then 0 to infinity. Obviously 0 is not included. So same is here also. So in this case also the range of function will be same. So they have the same range. Okay, let's talk about this particular. So obviously the graph is same like this. I am not discussing about the detailed graph, we are just concerned about the range. So this approximate graph is sufficient to find the range. So x power 21, it goes from minus 1 to 6. So let's say minus 1 is somewhere here and 6 is somewhere here. So 6 has open bracket. Okay, 6 has open bracket. So the graph is from minus 1. So x is from minus 1 to 6. What is the, if x is extending from minus 1 to 6, the graph of y when x is minus 1 to 6 is this and this much graph. That means this is the graph. This is the graph and this is the graph, or let's say this is the graph. This is the values of y, this and this. Okay, this. That means if I, let's say, make it more dark, this. This is the graph from minus 1 to 6. So obviously we can observe here that I need not to find the, okay, so that means what is this value at minus 1, the value is y is equal to minus 1, the value is minus 1, and at value 6 the value is 1 upon 6 to the power 21. Now what is the y value? So minimum value of y is, seems to be infinity. Okay, minus infinity. Maximum value is y is equal to infinity, but you observe here that between the this portion to this portion the graph does not exist. This is the this is the y values where there is no graph if we have to consider the x from minus 1 to 6. So how do we write it? See, the range of function will be obviously minus infinity to minus 1. Minus 1 has a, it has a, at x minus the close bracket. See, minus 1 has a close bracket. So we'll say minus infinity to minus 1 close, then union, then this from this value to this value. So this value is 1 upon 6 power 21, but 6 has a open bracket. So we'll consider open bracket 1 upon 6 to the power 21 to infinity. So this is the range of function. Okay. Next, I think 8. Y is equal to x square. This has a graph like this. So that means it's a range. If I talk about the range of function is 0 to infinity. Open bracket 0. We are never going to get 0. And I can extend it. Y is equal to x to the power 2n, where n is natural number, have same graph. Nature of graph is same. Nature of graph is same as y is equal to 1 by x square, and that's why range of this function will also be 0 to infinity. Okay, so this is the basic algebraic function. Next time we'll take the basic trigonometric function and let's say other functions, because the basic function are important. All the function, it's just a composed of the, or a combination. Basically it's either we can say combination or it's a hybrid. So combination or the composition. That combination means addition, multiplication, subtraction, division, and composition means one function is composed into other. So what I am saying that the overall function, if you take any function, either there is a composition or they are the combination of the basic function. So we will look at the all type of